Lesson 23, Important Characteristics to Describe. Example 1. Use appropriate descriptive statistics methods to describe the important characteristics of how many hours Sierra College elementary statistics students work in a typical week. That is, question 9 of the student survey. So, to describe the important characteristics of data, we need to focus on the three important aspects. That is, the distribution, or shape of the data, the central tendency, or average of the data, and the dispersion, or variation within the data. So the data in this example is how many hours Sierra College elementary statistics students work in a typical week. This data was collected through question 9 of the student survey, where the question asked, on average, how many hours do you work in a typical week? The data here is clearly quantitative. So we can use our TI-84 calculator to help us get our descriptive statistics. So I've already taken the time to enter the data into the calculator and name the list Q9. So to calculate some statistics, we could press Stat, right arrow to the Calculate menu, press Enter to select the one-var stats command. And then the lists, where I have data stored in my calculator, is found by pressing Second, Stat, to bring up all the lists with data. And using the arrow buttons, I can arrow till I find the Q9, question 9 data. With the cursor next to Q9, I press Enter to select. And then when I press Enter to execute, the calculator finds all kinds of descriptive statistics for the number of hours Sierra College elementary statistics students work in a typical week, including X bar, the sample mean, which is equal to 17.977, and the sample standard deviation, S sub x, which is equal to 13.692. And the N, the sample size, is 44. Using the arrow buttons to navigate down, we can see more statistics, including min x, which is the minimum data value in the sample, which is 0. So the lowest number of hours an elementary statistics student at Sierra College works in a typical week is 0 hours, that is, they don't work. And max x is the maximum number in this sample, in this case 50. So the most hours observed in this sample that an elementary statistics student at Sierra College works in a typical week was 50 hours. MED equals 18, telling us that the median is 18 hours a week. Now, to determine whether we're going to use the mean or the median to describe our central tendency, we have to determine if we have any outliers. So the way we define outliers is outliers have standard scores that are 3 or more standard deviations from the mean. That is, the standard score is either +3 or higher or -3 or lower. So we could calculate the standard score for the minimum and the maximum data value to see if we have any extreme outlying data values. So to do this, we would press left parenthesis, and then the data value in question. In this case, let's do the 0, the minimum data value. Subtract the mean, which was 17.977 hours, right parenthesis, then divide by the standard deviation, 13.692. Enter. So the standard score for the minimum data value of 0 hours is -1.31, which is not an outlier. It is not -3 or lower. So now let's find the standard score for the maximum data value of 50 hours. To do this, we go right parenthesis, then we take the data value in question, 50, subtract the mean, 17.977, right parenthesis, divide by standard deviation, 13.692. Enter. The standard score for the maximum data value of 50 hours is +2.34. Although the standard score of 2.34 is unusual, it's not extremely unusual to be classified as an outlier. So 2.34 does not extend beyond the +3 or higher. So in this case, this data sample has no outliers. So the appropriate descriptive statistics methods to use when we have quantitative data with no outliers would be the mean to measure central tendency and the standard deviation to measure dispersion. The distribution can be displayed by producing any appropriate graphical method such as a distribution table, histogram, or stem and leaf plot. So we've already used the TI-84 calculator to calculate the mean and the standard deviation. So we found that the sample mean, x bar, rounds off to about 18.0 hours, and the sample standard deviation, S sub x, rounds off to about 13.7 hours. Now, as far as the graphical method that we can use to display the distribution of the data, the TI-84 calculator can also help us here because it's programmed to construct histograms. To use the TI-84 calculator to construct a histogram, we would press second, y equals, to get to the stats plot menu, and then press enter to select plot 1. In order to see the stat plots, we need to turn it on. So with the cursor blinking on, we press enter so that when we graph this, it will be displayed. Down arrow takes us to the type of stat plot we want. We want a histogram. So moving the arrow to the right once, twice, to put the blinking cursor on the histogram looking icon, we press enter to select. So now our plot 1 will construct a histogram. Down arrow. XList is the list where we have our sample data we're going to make our histogram with. So to find the list for question 9, we press second, list, and then using the arrows, navigate the cursor next to the Q9, press enter to select. So now we'll make a histogram using the question 9, number of hours Sierra College elementary statistics students work in a typical week. But now we need to define the window. So to define the window, we press the window button, and now we have to define the coordinates. X-min is referring to the minimum value on our x-axis. X-max is the maximum value on the x-axis, and XSCL is the scale on the x-axis, which is the amount at which we are counting by. Same thing on the y-axis. Y-min is the minimum value on the y-axis that we're going to be displaying. Y-max is the maximum, highest value on the y-axis we're going to display. And YSCL is the scale on the y-axis, or the amount by which we're grouping on the y-axis. So in this case, we know that the minimum number of hours worked was 0. So I could use an x-min of 0. And the maximum number of hours worked was 50. Remember, we don't have to start exactly at the minimum and end exactly at the maximum. We just need to start somewhere before the minimum and end somewhere after the maximum in order to cover the full range of data. So if I want to go from 0 to 50 in a reasonable number of groupings, I might think of counting by 5s. If that's the case, I'm going to go from 0 to 55 to give myself enough room to cover the whole range, and use a scale of 5. So on the x-axis, I'm starting at 0, counting all the way up to 55, counting by 5s. Now the y-axis on the histogram is the frequency axis. The frequency is the count, and the minimum is always 0. So we always start our counting at 0. So y-min is 0. And the y-max is the highest frequency that we'll count to. But since our calculator is going to construct the histogram for us, we actually don't know what the maximum frequency is going to be. So we'll just have to give a good guess here. If our guess isn't quite good enough, after we've graphed it, we could always go back and change it to a more appropriate selection. I tend to use the maximum frequency as the sample size, which is 44, divided by 2. The reason I make this selection is because very rarely do you get more than half the data falling into any one group. So a Y max of half the sample size is usually a pretty good start. Enter. So we're going to count from 0 to 22 on the frequency scale, counting by, well, let's go by 2s. Now that we've got the x-axis and y-axis set up, to plot the histogram, we just press the graph button. And there we have our histogram. The trace button allows you to trace the graph bar by bar on the histogram. So notice after pressing trace, the first bar is highlighted, and it tells you that it starts at 0 and goes up to just short of 5. So this would include the 0 through 4s. And then the end tells you the frequency. So there were 10 students that fit in that 0 to 4 range. And then right arrow moves to the next group, which starts at 5 and counts to the number just below 10. In this case, that would be the 5 through 9. And the n is 2, so the frequency is 2. So as I arrow through the graph, I could just see the frequencies go 3, 8, 8, 1, 5, 3, 2, 1, and 1 through all the ranges. Notice we get a high point here locally in that 30 to 35 hour work range. And then here we get another little local high point in the 15 to 20 and 20 to 25 hour range. And then the high point at the very beginning, which include the 0 hours. Pressing clear will get rid of the trace command and just leave us with the graph. Since we noticed that the maximum frequency here was 10, if we wanted to adjust, we could press Window and change the Y max from 22 to, let's say, 12. Enter. And then pressing Graph again will redraw the graph, changing the scale on the y-axis. Instead of going from 0 to 22, it goes from 0 to 12. So now that we've constructed our histogram to display the distribution of the data, looking at the pattern, we could see that initially it starts off very high in frequency, then goes low, and then goes high again, and then goes back to low, and then higher frequencies again, and then lower frequencies. This pattern where you have multiple low, high, low, low, high, low, low, high, low is referred to as a multi-bell-shaped distribution. Now, multi-bell-shaped distributions usually indicate that although we took a sample from a population, in this case, Sierra College Elementary Statistics students, when we collect the data on the number of hours they work in a typical week, it looks like they separate into about 3 different subpopulations of students with regards to work hours. That first peak included the value of 0, and students who work 0 hours a week do not work. So one subpopulation would be students that do not work. The next peak occurred in the range of 15 to 25 hours. And students who work about 20 hours in a typical week are students that are classified as working part-time. So the second bell curve in this multi-bell shape refers to students who are working part-time. And then the third peak occurs in the range of 30 to 35 hours, and then continues on into 40 up to 50 hour range. And students who work in that 35, 40 hour range are students who are classified as working full-time. So this multi-bell-shaped curve indicates that we've got a group of students who work full-time, and then a group of students who work part-time, and then there's a group of students who do not work. Now we could take each of these results, and then using words of the problem, we can give a description of this data. The number of hours Sierra College Elementary Statistics students work in a typical week displays a multi-bell-shaped distribution, with a mean of 18 hours worked in a typical week and a standard deviation of 13.7 hours worked in a typical week.